Hi everyone in Algebra 3. This is going to be your new material on lesson 58. Lesson 58. And on this lesson, you are going to want to take out some notes because we are going to be learning another step-by-step problem that you will have to memorize for any test that you will take in the future. So the distance between a point and a line and the narrow and wide parabolas. So the distance between a point and a line, there are 4 steps we are going to follow. And the first one of these steps is going to be to find the equation of the line that is perpendicular to the given line and goes through the given point. So they're going to give you a line. You have to find the perpendicular to that line that goes through another point that they give you. Then we're going to find x by setting the original line and the perpendicular lines equal to each other. You're just going to set them equal to each other and then solve for x. Then after you solve for x, you're going to solve for y by plugging that into either the original line or the perpendicular line. And then lastly, we are going to take those 2 points that you found, so the given point in the problem, and then the x and the y that you found in steps 2 and 3. Sorry, this should say 2 and 3 to solve for the distance formula. And the distance formula you should already know. Okay, so we're going to practice this when we go to the lesson, but the next thing we're going to look at is narrow and wide parabolas. And what this means is that whenever you have to factor out a value before completing the square, this is what's going to make it. Bigger number would be a narrow or a parabola, and then a smaller number would be a wider parabola. And I will show you how this works when we look at our lesson. So now what we're going to do is we're going to look at number 9, and we're going to follow the 4 steps that I gave you before. So that starts with find the equation of the line that is perpendicular to the given line and goes through the given point. Well, my original line is going to be y is equal to 1/2 x minus 1, and my given point is going to be -2, 4. So if I'm trying to find the perpendicular to this line, in step 1, I'm going to take the negative reciprocal of the original slope. So I flip it and make it negative. So this would become -2x plus b. And it's going through the given point, so I have to plug in this point right here. That would be 4 is equal to -2 times -2 plus b. Now what you'll see is that -2 times -2 is actually 4, which means that my b is actually equal to 0. So my perpendicular line is going to be y is equal to -2x, because again, there's no y-intercept. It's crossing at 0. Step 2 is to solve for x. We're finding out where this line is crossing this line, at what point. So you're going to set this line equal to this line. So step 2 would be set the two y's equal to each other. So I have 1/2 x minus 1 is equal to -2x. Now, if you want to get rid of that fraction, you're going to multiply the whole thing by 2. That would give you x minus 2 equals -4x. Now, if you move the x to the left-hand side, I get 5x. Move the 2 to the other side gives you 2. Which means that it's going to cross at the coordinate x is equal to 2/5. Now what you're going to do is to find the y-coordinate at which these two lines are intersecting, which means that you need to plug this into either the original line or into your perpendicular line and solve for y. So step 3 is to solve for y. I'm going to plug the 2/5 into this equation here. So y equals -2 times 2/5, which means that y is going to be equal to -4/5. Now you're not done yet, because your last step is to find the distance between this point here and this point here. So step 4 is to use the distance formula. And the distance formula is this. So square root of x1 minus x2 squared plus y1 minus y2 squared. So when I plug this in, and this is going to get a little tricky because you have fractions, my x1 I'm going to put as -2. So -2 minus 2 over 5 squared plus y1, which I'm going to use as 4, minus negative 4 over 5, which would turn into plus 4 over 5 squared. And you are going to need to make a common denominator. So a common denominator of 5. So that would be negative 10 minus 2 would be negative 12 over 5 squared plus 4 times 5 is 20 plus 4 would be 24 over 5 squared. So you do need to evaluate this. Now, 12 squared is going to give us 144. And then 24 squared is going to give us 576 over 25. If I add 144 to that, I get 720. And that does not square root out evenly. So when I do this, I have 144 plus 576. I'm going to simplify that square root. So if I divide by 2, then divide by 2, that's 2 root 180. Then divide by 2 and divide by 2. That's going to be 4 root 45. Then I'm going to do divided by 3 and divided by 3. So that would be 4 times 3, which is 12, square root 5 all over 5. And that would be your answer for the distance between a point and a line. So it's a 4-step problem. We followed all 4 of those steps to solve for the distance between a point and a line, and that was number 9. Now we're going to look at number 10. So number 10, we're going to be completing the square to graph the parabola. So this problem is going to start the same as our other problems started. You're going to start by putting all the x's in parentheses. So y would be equal to, and then negative 2x squared minus 8x, leave the 4 on the outside. Now I'm going to, before I can complete the square, I have to factor out this negative 2. So that would become negative 2 and then x squared plus 4x, leave a space, minus 4. Because when you take out negative 2 out of negative 8, it would be positive 4. Now I'm going to complete the square. So I'm going to leave the negative 2 because that's just determining that my what the shape of my parabola is going to be. So it's either going to make it narrow or wider. But again, what we took notes on before is that if it's a larger number, it's going to be narrower. If it's a smaller number, it's going to be a wider parabola. So now I'm going to complete the square. So you take half the term that's attached to x, so half of 4 would be 2. But when you square that, you get positive 4. But don't forget, because you factored out the negative 2, this is actually negative 8. So I need to do the opposite to the outside. So instead of subtracting 8, I'm going to add 8. Because this is a negative 8, I do the opposite to the outside, which is to add 8. Now negative 4 plus 8 would give me plus 4. Now this negative sign tells me that it's going to be a sad face parabola, so it's going to face down. The x plus 2 is going to be my axis of symmetry. So I set that equal to 0 will give me x is equal to negative 2. Then this right here is my vertex. So where on the axis of symmetry am I starting? Now I'm going to tell you where this 2 comes into play. Now for my x and my y chart, I normally have 1, 1, 2, 4, 3, 9, 4, 16. If you kept going, just all your x values squared. But now that I have factored out this negative 2, I'm actually going to multiply all of these variables, all my y values, by negative 2, which would give me negative 2, negative 8, negative 18, and then if I wanted to keep going, it would be negative 32. So when I graph this, that's going to change how narrow my parabola is going to be. So it's going to be negative 2 up 4. So I'm going to have my parabola looks something like this. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So my axis of symmetry is that x is equal to -2. So that means at -2, I'm going to have my dotted line. Then on that dotted line, I'm going to put my vertex, which is at +4. 1, 2, 3, 4. Now, this is where I'm going to draw my parabola. So from my vertex, I'm going to go over 1, down 2. Over 1, down 1, 2. And then I'm going to go over 2, down 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Notice that my parabola is a lot thinner than it normally is. The larger the number, the narrower your parabola is going to be. And now I'm just going to connect my points. And that right there is going to be your answer. So the factoring stays the same as you would before. The only thing that's going to change is that when you are plugging it into your chart, you're going to multiply whatever you factored out by this bottom row, and that will tell you how many spaces to go over and up or over and down from your vertex. And that would complete your new material on lesson 58. This lesson is not going to be stamped until Tuesday of next week. I hope you guys have a great weekend. Bye.